Okay, this is Module 10, Practice Problem 4. The question has a chemical reaction. Sodium bromide plus silver nitrate turns into silver bromide and plus sodium nitrate. Notice the nice thing about this particular question is all the stoichiometric coefficients are 1 because they're not written. So that's nice. What we're dealing with, the question asks if a chemist needs to produce 150 grams of silver bromide. This is silver bromide. So we're given grams already of 150.0 grams of silver bromide. How many liters of silver nitrate? How many liters of 3.5 molarity or molars of silver nitrate? This is silver nitrate. So we're given information about silver nitrate. We don't know liters. That's the question. That's what we're shooting for. But we do know that we have 3.5 molars of silver nitrate. So from that, basically, we can go to stoichiometry. Basically, we've got to go from, put the blue again here, we got to go from this grams, convert that to moles, and then figure out the mole relationship, the ratio, moles one to the other. Nice thing about this particular problem is that it's a 1-to-1 ratio, so that part's going to be really easy. And then we've got, once we figure out the moles, we've got to convert that to liters, which is the end of our question. So that's the process we take. And to go from moles to liters here, we just got to remember our formula. Molars equals moles over liters. So if that's true, a little algebra will show, to solve for liters, we want to get liters on one side. So let's get liters on this side. So let's multiply that by liters, this side by liters. That gets liters on this side. And let's divide this side by molars, dividing this side by molars. That takes the molars off of the left side. So essentially we're given an equation that we can use now with liters, moles, and molars. Liters on one side, moles and molars on the other side. So liters essentially equals moles over molars. And we will, once we figure it out, we will have moles and we will have molars. So we can solve for liters and get to the end of the question. More, if you're still having trouble with figuring out how to get to moles from grams, let me run through that real quick in a different color here. Essentially we have 150.0 grams for 1 times, well, how many grams are in 1 mole? So we got 1 mole, how many grams are in 1 mole? And those grams, where we get that is, once again from the chart, we're just talking about silver bromide. So this is fairly simple. Silver is 107.9 Ag, 107.9. So 107.9 plus bromide, which is 79.9. 79.9. We do the math and we'll get a number here. Okay, so when I worked out this problem, I added these two numbers, 107.9 plus 79.9. I got 187.8. I kind of crossed that out since I've just made it a little bit simpler. And then I took everything on the top, 150 times 1 divided by 1 times 178.8, essentially 150.0 divided by 187.8. And I got a long number, my calculator, but I can keep, each one of these has 4 significant figures, so I can keep 4 significant figures of this. 0 is not a significant figure, but I did get 0.7987, and since the grams cross out, we're left with moles, so it's 0.7987 moles. So that can go here, 0.7987. And since it's a 1-to-1 ratio, there's a 1 essentially here and a 1 essentially here for the stoichiometric coefficients. So if we get 0.7987 moles of silver bromide, we've got 0.7987 moles of silver nitrate. So in order to get liters, we've already decided earlier that we just changed up the original formula, molars equals moles over liters, and now we got liters equals moles over molars. We've got moles, 0.7987, and we've got molars, 3.5 molars. I put moles, I put molars here at the bottom, and we can calculate that out. Okay, just wanted to clarify that molars is the same thing as moles over liters. So I can cross that, so I can see that we're basically dividing moles divided by moles over liters. The number I get is 0.2282. 3.5 is only two significant figures. That's what's going to limit our answer. So essentially I can only get two significant figures off of this. So that's going to be 0.23. The reason I got 23 is because 8 makes that second 2 go up to a 3. It was 0.2282. What is my unit? Well, moles over moles cancel each other out. And 1 over liters is another way of saying liters. And that is our answer. So basically our answer is that we are going to have 0.23 liters of sodium nitrate. We got that because we figured everything else. 0.23 liters of that sodium nitrate. Let's put a square on it so we can find it, and that is question 4, Module 10 practice problems.